Good morning, everyone. Welcome to Carolina Code. My name is Cameron Presley. If you're in the right room, i.e. the only room here, you are here to learn about functional programming through first principles. Quick show of hands. How many people actually do functional programming? How many people actually know TypeScript at all? How about C#? Wonderful. So a little bit about myself. I am a Microsoft MVP. All that means is I love talking about technology to people like you. I'm not employed by Microsoft. I don't do anything with them except that I do stuff for the community, and I love doing that. I work for a consultancy called Lean Techniques. What do? We make companies awesome. That's either through digital transformation, helping developers be better, and honestly, just help companies figure out what the heck should they be doing, right? Sometimes they have a lot of choices and don't know what to do. If you want to know more about that, come hit me up after this talk. But I bet y'all didn't realize this. We're going to build something today. In fact, we're going to build it in 25 minutes. Congratulations. We've all been volunteered to go help out a robotics club build out a rover. Thankfully, we're not hardware engineers. At least you don't want me to be. I'm partially colorblind and you don't want me near a soldering iron. So instead, we're going to build an emulator that translates some commands that we're going to send to this rover, and it's going to allow it to move forward, move backward. We're going to build this using functional programming concepts, even though you're not familiar with what those are yet. But there's a couple of restrictions. First and foremost, we're going to design our code in such a way that engineers can't ship bugs because they wrote code in a crap way. How many times have you all worked in a code base where the code would allow an engineer to do something that would severely violate the business rules, right? So how'd you catch it? Unit testing? TDD? Production? Right? It's okay, we're all friends here. Well, instead of writing code that way, I'd much rather write code in a way that you can't ship bugs, because if you tried, the code literally wouldn't compile. Your CI pipeline's going to catch it. And you may be thinking, Cameron, that's impossible. Not quite. Let's take a look into that. And I'm not the only one who thinks this way. Jeff Atwood from Coding Horror, you may also know him from a little thing called Stack Overflow if you've ever used it. He wrote way back in an article called Falling to the Pit of Success that a well-designed system makes it easy to do the right thing and annoying, but maybe not impossible, to do the wrong thing. Long story short, remove the friction. Let your engineers do the right thing. So at a high level, here's the requirements of what we're going to build in 24 minutes now. We've got to build some rover, this idea that it's got a starting point, X and Y. So think like a two-dimensional plane. Think back to like high school math here a little bit. And it's going to have some direction that it can face in, either north, south, east, or west, right? We're not dealing with any northeast, southwest type stuff. And there's 4 commands it's got to be able to know. Move forward, move backward, turn left and turn right. That's it. We'll talk more about what exactly those commands are going to do, like implementation, but at a really high level, that's it. So let's talk about data modeling. How can we design our data and our models in such a way that developers are going to do the right thing? Well, what I like to do, and for those who come from an OO background, you may be using the trick to identify the nouns. Well, in our case, the nouns aren't too bad. We've got a rover. That kind of makes sense. We don't have a rover, what are we doing here? Rover has a direction. Oh, that's a noun. That sounds like a type we're going to need. And then there's some of these commands that we're going to be running through, okay? So we've got these models, and now we get to figure out how to implement them. Now, what I like to do is I like to draw this little dependency graph, because you see how rover is pointing to direction. That's kind of some signifying relationship. Flip that around. That tells us the order we get to write this code in. So let's start with direction. So direction can only be one of 4 values, right? North, south, east, west, that's it. It can't be anything else. So in a lot of functional languages, they'll have this concept known as a union typed. In TypeScript, it's called tagged unions. Other languages, it's called discriminated unions. But at the end of the day, it is known as a union type, also known as a sum type. And in TypeScript, we have that, and this is what we can define direction at. And if you have no experience with TypeScript, you might squint your eyes and go, wait a minute, this is an enum. Not too far off. We'll talk more about that later if time permits. But by defining direction as it's saying it's either north or south or east or west, that's how you read that vertical bar, I've already eliminated a whole slew of bugs from the system. Don't believe me? If I try to create a value of direction with the type of direction and try to assign it the string kumquats, it won't compile. And TypeScript is telling me, hey, I can't do that. That string's not a valid option for this type. Sweet. I've already eliminated a whole slew of errors that could have happened if I just tried to model this with strings or even just integers like a native enum would have done. Let's take a look at the next thing, commands. Commands are a little bit trickier because there's 5 values, but we know them, they're stacked, they're not going to change, so we can use that same trick. Strings here again. Now, what you're seeing in this presentation is that we're using these union types as strings, but they could have been anything. They could have been records. They could have been completely different shapes. That's a little bit more of an advanced topic that I won't have time to get into today, but do not get stuck in the fact that each of these options have to be the same type. Absolutely not the case. So by defining a command like this, I can't make a command called platypus, one of my favorite like bizarre creatures in the world. I can't make it a command because I didn't say platypus was a valid command. I wouldn't know what a rover would do if it got told to platypus. Would it lay an egg? Would it hide underwater? I don't know. Would it try to poison someone? Platypi are confusing. So we've got direction and command down. Let's take a look at rover. Now this is a little bit different because instead of saying that direction is a thing or command is a thing, we're saying that rover has things. Rover has an X, it has a Y, it has a direction. The minute you start hearing that has, you've got a product type because it's a combination of values. So we can actually model that in most functional languages, you'll kind of hear them told as a record, but product type is what it is. In this case, we're going to export this type called rover, and it literally is going to say what it is on the tin. Has to have a property called X, that's a number, Y, that's a number, direction, that has to be a direction. Remember the type we just defined. So this doesn't, you're probably looking at me like, well, Cameron, this seems common sense. It is, but look how much cool stuff we can do now. The minute I define the type and I try to new up a rover and say, hey, it's got some wheels, TypeScript smacks me on the wrist, go, can't do that. You didn't tell me that rover had a property called wheels, so that's not going to compile. The other thing to note here, and I'm going to go back a slide, is that any type any object that has an X, Y, and a direction with those types will be valid. So it's going to model any number by direction. But there's a small flaw with the way we've done rover. Here's a function I've written called log rover, and it's pretty cool. It delightfully allows me to log a message that says rover is at some X and Y facing direction. Anyone want to tell me what looks a little bit wrong about this? Yeah, so this is a void function called log rover. I would assume that it's going to log. But in reality, this is actually changing my rover. Ooh, that's not obvious from a caller that would happen. I would have had to go look in the code, right? So imagine if I had written this, I had logged the rover, and then I get complaints from my customers or clients saying, hey, this X value is not correct. It seems to always be changing, even though it's not received any commands. That's a bug, right? So how can I prevent this? Well, it's because the problem is the way I define rover is not correct. What I can do is I can update my definition of rover and make all of those properties read-only. By doing that, that allows those values to be set in stone. They can't change anymore. So now if I go back to that code that was busted before, it literally won't compile now because it says, hey, wait a minute, you're trying to update X, you can't do that. You said it was read-only. Not going to work. So if I want that busted code to work again, I have to do this. I've got to update the signature to say it's going to return back a rover, and then I have to make a copy of the rover existing by using the spread operator, and now upsetting X. This looks more obviously wrong now, right? If I was calling log rover and I saw it was returning back a rover, my code senses would be tingling here going, what in the world is this thing doing? Cool, we made wrong code look wrong. Joel Spolsky, you would kind of know him as one of the guys that kind of did something with Excel, kind of created Visual Basic script for that. You may also know him from Fog Creek, and he also kind of did a thing called Stack Overflow. You might know him from a little bit. He wrote about you deliberately architect your code in such a way that your nose for uncleanliness makes your code more likely to be correct. This is the real art, making robust code by literally inventing conventions, right? Originally, when you looked at log rover, the types or anything didn't make it seem like it was wrong until you looked into it. Now the types make it look wrong. It immediately is going to flag on PRs. Make sense so far? Cool, you just learned immutability. First principle of functional programming. When we say something's immutable, we're saying that its state cannot be modified after it's created. And this sounds really simple, but this is kind of a big deal because keeping track of changing state is hard. You literally just got done listening to 2 talks this morning that talked about keeping track of state sucks, right? JWTs and dealing with Postgres, right? In code, it's even harder, especially for those who've ever worked in an app that had global shared state. Now you know this code, something changed this. I'm not sure where or how. You have no idea. Immutability solves a lot of those problems. So we've knocked out this requirement, knowing the initial starting X and Y in some direction. Now we gotta start implementing commands. Let's take a look at move forward and move backward. So the rover is really dumb. We're gonna make this somewhat simple. So when the rover's moving forward, it depends on what direction it's facing. So if I'm facing north and the rover's told to move forward, its Y value is gonna go up by 1. We're gonna do a little bit of a cha-cha slide here. If it's facing south, Y will decrease by 1, and X will increase and decrease by 1 depending on east or west. Now you may think I'm about to write some code. Fools, I'm not gonna write any code. This is a tech conference. I don't write code live. You guys are crazy. But here's something that we gotta know about the design. Hey, this rover's gotta update its state. Either its X or Y value. But wait a minute, we just said the rover was immutable. So that means we have to create something that will create a new rover, right? Well, let's see what that would look like. So I've got a rover on the left, and it's gonna map to a rover on the right. So all the possible rover combinations are on the left. So rovers can be, I don't care about their X or Y values, they can only be facing 1 of 4 directions, right? So I've broken them down that way. And then over here, I've said, all right, well, here's all those rovers with their state changed. And then I'm gonna do a mapping. I'm gonna say, well, if the rover's facing north, it's gonna be wherever it was, Y plus 1. South is gonna be Y minus 1, so on and so forth. Make sense so far? Here's the $1 million question. Is everything in the left mapped to a single thing on the right? Yeah? Cool, you now know what a function is. If you look at the mathematical definition of function, it tells you it's a mapping between 2 sets, such that every element in the first set maps to a single element on the second set. But Cameron, we're developers, we're not mathematicians. Ah ha ha, I got you again. Let's update it for developers. A function is a mapping between 2 types, such that every value of that first type maps to a single value of the second type. Let's take a look at mappings that aren't functions. Let's say I've got this mapping where I've got months being mapped to a number of days. So I've got all the possible months on the left, so ignore the ordering, it'll make sense in a minute, but everything from January to December. And then I've got the number of days in each month, right? There's no months with 32 days, there's no months with 27 days. Well, January maps to 31, makes sense, January has 31 days. March maps to 31, that's fine, no problem, so on and so forth. Oof. How many days does February have? It depends. Don't you love working with code where the answer is, well, it depends? Super reliable, super easy to troubleshoot, right? This isn't a mapping because February is not enough information. It can give us 1 of 2 answers. I don't want the computer to say, well, maybe when it's running my application, that it's kind of a big deal, right? So that's not a mapping. Let's take a look at another one that's busted. So in this case, we're going to go from the set of all numbers, so any possible number type, to month names. So you may see where this is going, right? 1 goes to January, 2 goes to February, so on and so forth. What does 13 get mapped to? Well, if I'm in JavaScript, I'll just do mod 12 math on it, and then I'll end up with February because I'm off by 1, because of course I am. But in a lot of other code, I'd get an argument exception. Wait a minute, an argument exception is not a month name. I don't know about you, but I don't know anyone who was born in argument exception month, right? The reason why I call this out is this means that their type systems are lying. We have functions that say, I'm always going to do this thing, but sometimes they won't. So what was the point of the type system, right? So here's our mapping that is good. Let's write the code for it. Still not going to write it live. But we've got a function called move forward. We're going to do a switch statement on direction. And because we said direction can only be 1 of 4 possible values, those are the 4 cases I have to write. And in fact, if I forgot one of these cases, TypeScript's going to smack me on the wrist and go, hey, buddy, you forgot to write this case, go write it. Once again, preventing that whole developers from making mistakes issue again. Right? So I've got my logic. And for those of you who have a testing background, This doesn't seem to be too hard to unit test, would it? New upper rover, call it in, make sure that the x or y value got incremented by 1. You don't have to worry about any of the other state changing on you because it's immutable. Isn't that neat? So why do we care? I kind of hinted at before. It's hard to debug inconsistent behavior. How many times have you worked on a bug where the user said, well, I did this thing, and you try to reproduce it and you can't? That's fun, right? Also, I'm a huge fan if I'm using a typed language, like TypeScript or C# or something, I want the damn type system to work. If it tells me it's going to do this thing, it needs to do it all the time, not, well, sometimes it does, sometimes it doesn't. So at this point, as you can imagine, moving backward is going to look very similar, so I've kind of skipped over that. But we've got move forward, move backward. Let's take a look at left and right. So we've got a really fancy rover that it's like 0 turn radius. So when it rotates, it's literally rotating in place. We don't have to worry about the x or y value. So if we're facing north, we'll rotate to the west. West would go south, south would go east, east would go north. That's kind of the ordering there. So here's our mapping, right? You've kind of seen this trick before where we're going from rover to rover. Feels like there's like a rover to rover, come over rover. Anyway, so cool. We've got our mappings, right? North goes to west, south goes to east, so on and so forth. So because we have a function, everything on the left is mapped to a single thing on the right, this function is actually really easy to implement. In fact, it looks suspiciously similar to the move forward. All right, so far so good. But now we come to the fun part. We've got all these little functions running around. But these functions aren't going to solve my problem. I actually have to build the application. So let's go do that. Let's talk about gluing these things together with the pipeline. So at a high level, what the user is going to be able to do is that they're going to enter in some input. We're then going to take their input, and then we've got to map it to one of those commands, right? Move forward, move backward, turn left, turn right. And then once we've mapped it to a command, we got to figure out what function do we call, right? Do we call the move forward function, move backward function? Which one do we call? But once we've got that function, we're going to invoke it with the rover, and then we're going to update it, which means we're going to throw out the old one and get the new one. Sounds complicated? Don't worry, we'll go over it. User enters input. This is from the command line. Done. They're going to give us some string, right? You can do that in any language you like. Okay, let's now map it to a command. So let's see what that would look like. So we've got a mapping of all strings that the user could give us, and it's got to map to commands. So here's some strings on the left, here's the commands on the right. And so we're doing some case insensitivity here. F's move to forward, B's to backwards, L's to lefts, R's to rights, Q's for quits. But the problem is that said on the left, all strings. There's a lot of strings that I didn't put in there, aren't there? Like platypus, I told you he'd be making a comeback. What's platypus map to? Anyone want to take a guess? It can't. There is no clear mapping for this, so we don't have a function. That's kind of a problem. So, and I kind of hinted at this, right? And this is totally happening when we deal with users because users are jerks, right? Let's face it, they're going to break your stuff. So when you run into this situation where, hey, I can't handle all possible inputs, you've got two solutions you can do. The first solution is try to restrict your input to valid values. You saw us use that trick a little bit earlier, right, when we were defining the commands and the directions. Because we did that, we got to throw out a lot of problems. In this case, it's not going to work because there's no way for me to force the user to do the right thing in this case. So I've got to change it. I've got to change what my possible outputs are. Now, in some languages, this could be by adding null. This could be by throwing an exception. But I don't like those because then I got to deal with all that curmudgeon down the road. So here's what I'm going to do. I'm going to add a new command. I'm going to introduce a new one called unknown. Last entry. Right. So now what I'm going to do is say, cool, that platypus, yeah, it's going to get mapped to unknown. And not only is platypus going to get mapped to unknown, if it's not one of those 5 values, map everything else to unknown. It's my default case. Sweet, I've got a function here. Done. Now the fun part, command map to action. So I've got all my possible commands and all the possible functions that go from rover to rover. So there's all my commands. Here's rover to rover. So the move forward command moves to the move forward function, backward to backward, so on and so forth. Oof. I've ran into this problem again. What do I map quit and unknown to? Right? Think back to what I just said. You either have to restrict the inputs or expand the outputs. Well, I can't restrict the inputs because quit and unknown are valid commands, right? So my only option is I got to expand the outputs. So what function do we return if we get the quit or unknown command? Another way of thinking about it. I need a function that does nothing. If you've told me to quit, okay, cool, I'm going to stop processing. If you've given me an unknown command, I'm not going to try to move. That sounds dumb. I'm going to not do anything. I'm going to stay still. So that means I need to write a function that does nothing. What would that look like? It just returns back whatever you pass in. For those of you who have a little bit of functional, you'll know this as the identity function. But in this case, you pass in any rover, it returns it just as is, right? But now that we have that do nothing, we can map quit and unknown to it. And so here's our switch statement, quit and unknown. In those cases, we say return do nothing. Last steps, and these two are kind of coupled together, is we got to now call action with that rover and update it. So I'm just going to show you the solution. The part that you care about is kind of like right through here in this area, right? So we've got a rover, we've got our command. While command's not quit, we get input from the user. We convert the string to a command. We convert the command to an action. And it's that last line underneath that red bar that says rover equals action rover. That's where we're updating it. But remember, we're not actually changing like a single part of that rover value. We're actually throwing out the whole reference altogether and getting the new one. Because of that, rover's only changing in one place. So if rover's not working correctly, I know exactly where to go, not throughout my whole application. But there's something interesting going on here. And it's these two lines I've got highlighted in red. I've got one function that says string to command, and then I've got another function that goes from command to action. I wonder if I could do something about that. Because in reality, what those two lines are doing, if we're looking at mapping, is this gargantuan thing, right? Go from strings to commands to rovers. Why can't we bypass that middle function? We can. Welcome to the third concept, composition. So I'm going to write a type here, and this is really just to help make the compose function read a little bit cleaner, but I've got a type called func that says if you give me some input of type A, I'm going to give you back some output of type B. And then compose, what that says is if you give me a function that goes from A to B and another function that goes from B to C, I will give you back a function that can go from A to C directly. So for those of you who've got like an algebra background, this may be clicking a little bit here, especially with the G and F. But once I've got this compose function, I can go back and I can create a new function, right? I can say, cool, I'm going to make a new function called convert string to action. And to build it, I'm going to say compose convert string to command with convert command to action. And once I have that, I can then use it inside my while loop. That's pretty cool. I just took functions that I built and made a new function just by composing them. The only reason why this works is because I was working with functions. Remember, everything on the left has to map to something to the right. If that wasn't true, then composition doesn't work. That's why all this stuff builds on. And if I don't have immutability, it's really hard to write a good function to write a function because data could change on you during mid-invocation. So all these three concepts build upon each other. So wrapping up here, immutability, it removes the ability for random access to internal state, and by doing that, that means it reduces your complexity, i.e. you're not having to work as hard to troubleshoot stuff. Functions, they're just mappings from one type to another, such that everything on the left is mapped to a single thing on the right. And then composition is really what I was just talking about, right? It allows us to compose those smaller programs into bigger functions, and it's really cool, and you should do it more often. But that's it for me on time. So thanks for letting me come hang out with you all this morning at Carolina Code. If you want to know more about this stuff, feel free to send me an email at cameron@softwarementor.com. If you're just wanting to get the slides, you can trust me and scan that QR code, and hopefully I didn't lead you astray. But if you don't trust me, feel free to go to that Zulip app, go to 2024 Talks, and look for the topic called Learning FP First Principles. I've already posted a link there. Otherwise, thanks so much, everybody. I appreciate it.